Start recording. Okay, so chapter 15 and bonus. So he starts by talking about minimalism, which is basically saying that we have powerful enough primitives, so now we can make a prelude of sorts, which is quite cool. It's very interesting how many things you can do with the score. And
I like the phrase under the picture of the library, by the way. I thought it was quite fitting.
built with just leather, paper, wood, and ink. And you have all of this. Yeah, it fits. It fits. So the first thing is, which it's my first problem actually, is that we are defining some useful quote unquote constants for our programming language, and he calls those atoms. Um, I think it's quite a thing because in modern languages, atoms they have different meaning. So choosing to make
Yeah,
the booleans in the new atoms, I don't know if that was the best naming choice.
well, atoms are like he chose the name because it's what's being historically used in the Lisp literature. Um, because in Lisps, in traditional Lisps, you have S expressions, right, which are either pairs of S expressions or atomic values,
Mhm.
which are indivisible.
Mhm.
Traditionally symbols, but usually you also have primitives like numbers and strings and what have you.
Yeah.
Uh, so that's the distinction, right? You have atoms which are indivisible, and you have pairs essentially, which add structure built out of simpler stuff.
Mhm.
Um, I don't like the word atoms here, not because of that, because I think it's fine to follow the traditional Lisp literature, even though this is a modern book. My actual problem is that new, true, and false are literally just they are actually evaluated to other things, right? When you say atom in Lisp, usually you think of an unevaluated value, right? So the
Mm.
actual symbols new, true, and
Yeah, that's
false.
something that I haven't thought about. That's true. But well, he decided to make booleans numbers. So I think if you're already doing the cursed path, this is not as bad, I guess.
By the way, I have nothing against using numbers as booleans. My problem is actually with the specific numbers that were chosen here.
I do have
Like,
problems with using numbers as as this. I
like
do
my
have it.
problem here is that while 0 and 1 are fine from a number theoretic perspective, from a computing perspective, it's actually better to use 0 and minus 1.
Yeah, because then you can I guess you can make optimizations with the binary or something like that.
No, 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 because then your bitwise operations and your Boolean operations are actually the same, you
Yeah.
see?
So you can make you are exploiting uh, the minus one and the other thing. Yeah, I haven't
Yeah.
thought about that either. That's a good point. But well, I have
And by the
problems
way,
with making
and by the
syntax
way,
sugar for numbers using names that have meaning. I do have problems with that. But I already said
uh,
this before when he implemented booleans chapters ago. So
do you have problems with having pi as a named constant in mathematics libraries?
no, because that's the name of the number. That's the name that we got that we provided to this specific number. We call this a one.
Yes, but in the context of Boolean expressions, this is actually the true value, you see?
No, it isn't. But in his implementation is because he is using numbers as the conditional criteria behind the hood. So this is actually like this is expected. This alias, these two aliases here. But I don't have to use the aliases, mind you.
You don't.
So anyway, yeah, it's not the biggest deal to me. But if I would do it, if I would have done this, I would definitely do it differently. Um, then we start going to the blocks, right? So the very functions and stuff like that for your prelude. So this is what the definition of a user-defined function. That so This is better, and he already showed this before. And then we start adding more stuff. So pack and unpack, which are basically synonyms of curry and uncurry, stuff like that. And then we have the
Uh,
do,
by
which
the way, can I
is
just say I really don't like the name unpack because
um,
in traditional Lisps, this unpack function is actually called apply. It already has a name.
I see, I see. Although I gotta be fair, given what this is doing, I kind of understand he preferring unpack, at least from
But
a
that's
newcomer's perspective. You disagree because you already knew apply before. Um,
well, yes, because eval and apply are the two classic Lisp interpreter functions, right?
I know that, but we know that. That's the problem. We don't. It's very hard
I
for us
think
to
this
evaluate.
I think this is perhaps a missed opportunity. He could have mentioned that unpack is traditionally called apply,
He could,
and that
definitely
would
could.
yeah, and that would have pushed it. It would have like shown
Culture.
a path for you to culture, yes, but also to get into the history of the thing that you were
Yeah,
actually implementing.
yeah. That
I
that's
think
true.
there's
I
value.
gotta agree with that. I gotta agree.
Yeah.
Then we go with the
Also,
do.
can I just
Go.
Also, can I just say I don't like the way the code is formatted with the hanging open brace at the end of the first line and then the hanging close brace at like that's not how you write in Lisp. It just isn't.
Uh, I think that you're right in the sense that this is not how you write Lisp, but this doesn't remind me. Um, how can I say this? The functions that he is defining, you were never gonna see them. You would only see what he's showing in the repo, ideally. I know that's not true because these are going in a file that you're reading and you're parsing and all that stuff. So this is it's his Lisp. But for me, it reminds me more of C though, because when I'm programming in C, that's exactly what I do. I put the open curly braces and the same line of the function stuff, and I also have the hanging things at the end. So this definitely is not Lispy. Definitely not Lispy. I also agree with that. And then we also have the do, which is basically begin, program. So we know those. And then we
Closure
have
do.
my first question, which I don't remember. I don't understand how this works. And I actually went back to the variables chapter to see if I missed something. I don't understand how this is setting x to 100 actually.
Well, the equal sign is the remember when you were he was implementing environments and assignments. And there
Sure.
were two assignment operators, right? One that defines a symbol in the closest and closing environments, and one that defines it in the in the oldest ancestor, which usually is the global environment, right?
Yeah, but do you remember when? Because this is the environment and variables chapter here. And I'm trying to find where is it talking about that.
Um, Conditionals, functions, variables. I think it's in the environment section, perhaps. Environment, new del, get, put, built-ins. That's not it. Define function. Yes, there's a section called define function where he
Chapter
introduces
11?
that. Yeah, chapter 11.
Okay, so here it is. So where is the
Uh,
equal thing?
F. Where?
And the funny thing is that I think I remember that. I think I remember two different ways and stuff like
Yeah,
that.
yeah. There was this whole talk where I went on a tangent about how this global define completely breaks any notion of locality, and you can redefine things in the global environment from a very
No, no, no,
deeply nested
no, but that
place.
was a different thing. No, that was the scoping issue. We were talking about the equals.
Where does it appear? Immutability, symbol syntax, function pointer, cyclic types, function type. Um,
Like the only thing that I didn't understand is that, like of the let. Oh, okay. So I found. Oh, no, but this is the comparison. That's not what we're looking for. Recursion.
okay.
And then we go to
Variable
strings.
evaluation.
Maybe it's before chapter 11, dude.
It might be after actually.
I am looking
Current
after, but I'm
environment.
not finding it.
It's on chapter 12 actually, I think.
Well, I already skimmed that. Apparently, I failed. So let's go back to
Yes,
12.
it's chapter 12. It's chapter 12. The section is called parent environment. It's where we switch from a flat environment to an environment that has a parent.
Sure.
And this is where the notion of having two different assignment operators is introduced. Is right there.
Oh, it's here. I see. Uh,
Yeah. So def sets the value of the symbol in the oldest ancestor of the current environment, which is usually the global environment, right?
yeah.
And equals sets it on the local environment.
Okay, now
So
this explains how
whatever.
this works. Because now I can totally understand this.
Um, can I just say that I really don't like the way he defines let here?
Seems fine to me. What's your problem with it?
The problem is that you have to write the do explicitly. Like I can't really think of a way that you would use let that wouldn't require a do. And he didn't add the do in the definition of the let, so you have to write it out every time that you want to use it. That seems like a usability failure.
I think you're right. He could. Yeah, I think that I think you're completely right. Because my argument would be that by forcing the user to do the do, you have an easy time in here because if the do was here, you would have to type check if this makes sense or whatever. But I don't think that's the case. I think it would be the same amount of work. So I think you're right. The do could be already like in place here, and things would be fine. Very very good point. I haven't thought about that as well. Logical functions. So this is basically not
Yeah,
or an and.
I really hate those definitions. They are terrible.
They are terrible.
Yeah, or he defined it as a plus. First of all, if -1 was true instead of 1, he could have just used bitwise not or and
He doesn't
then, and
have
it would have
bitwise
been.
operations.
Yeah, but he doesn't. He could have added them just for the sake of booleans, you see. But since he didn't, and he defines 0 to be false and 1 to be true instead of -1, I think he should have used a different set of definitions. So first of all, or should have been max, right? The function that takes two numbers and returns the highest value between them. And it should have been min and not, well, I can't really think of a better definition for not,
But that
and I'm
sounds
kind of
bad.
sad
You need
about
to
that.
define two extra primitives to do that instead of using what you already have, which is minus, plus, and times, and multiplication.
Multiplication by itself is not a problem. The problem actually is that plus can return a value that isn't a boolean.
But a min and a max is also. or would you check them?
Well, the thing about min and max is that if the inputs are booleans, the output will always be a boolean, which is not the case for plus.
That's also not the case for min and max. If I provide a true and a 7,
But in that case, your input is not a boolean. 7 is not a boolean because it's neither 0 nor 1.
I don't understand the logic. So if you have an operation that takes a boolean and returns a boolean, you are fine. Oh, your
The
problem
problem,
is that if I provide a 1 and a 1 to a plus, it's going to return a 2, which is not a boolean.
yes, exactly.
That's the problem, I see.
Yeah.
Okay.
Like, multiplication is kind of okay. I don't like it because it's inefficient. Uh, like, multiplication is expensive compared to plus, for instance. So I wouldn't use it for that reason, but semantically it's actually fine. It's actually the least offensive of those three definitions.
That's actually not true, because his definition of a true is everything that is not a zero. You can read that in previous chapters, I'm pretty sure. Actually, you can check that.
Well, yes, that's in the definition of if. But the canonical boolean that he chose for true is 1. And given that true is 1 canonically, even though semantically you can use anything other than 0, multiplication is fine because if you give it two booleans, so 0 and 1, or 0 and 0, or 1 and 1, the output will always be a boolean. So I'm okay with that, semantically at least.
No, I agree 100% with you if he defined that the only available booleans is 0 and 1. But he didn't. That's the catch.
Yeah. He really should have just gone with 0 and -1 and used bitwise operations and called it a
Yeah,
day.
but he doesn't have bitwise operations, my friend.
He
Uh,
should. They are
sure.
available in the hardware. Why not expose them?
That I agree. I agree. But I think he picked the most popular operations because like newcomers or whatever. Miscellaneous functions. So we have flip, which is it does exactly what you would expect. We have ghost, which I don't know how to feel about it, and we have composition. Um, so something really interesting that his language is capable of doing is this. So this is basically applying a def and swapping these things. And then
Yeah.
you can ask for ask and it's a one. Same thing with this, and so on and so forth. Uh, no, that's fine. Yeah, that's fine. What about Ghost though? Because Ghost is basically like a NOP. It does nothing, I guess.
Yeah. Like the author himself admits that he couldn't think of a use for this function, and I can't think of a use for this function. Like, why? I mean, I guess from an educational point of view, yeah, this is kind of interesting. You can define a function that is like it's not there, even though it is.
Yeah, sure.
But I don't, but I don't see a purpose for it beyond just that curiosity. So
Yeah.
yeah,
So then we have Compose, which is really cool. It does exactly what would you expect. So you do something, then you can compose functions to create another function out of that.
I actually dislike the compose that is defined here because actually, this is a bit of a deeper issue because this language is not simply arithmetic. That is, you can have functions that take a dynamic number of arguments that you cannot statically know. It's basically impossible to define a fully general composition operator or a set of composition operators that work with the fact that the functions can take more than one argument.
Sure.
Like,
Yeah, but I think I can say the
yeah.
same about like racket, closure.
Actually, Racket is pretty decent in that regard because it has some arity information as opposed to none. So it can do some interesting things with the composition, but yeah, it's still not simply edited, so you don't have the full potential of this set of
Yeah, no,
operators.
but what I am
So,
saying is that if you dislike the composition here, I think you should dislike the other many compositions in other places as well.
but I do actually.
Oh, okay, so
It's
that's
kind
fine.
of yeah, that's part of the reason. Uh, that's actually part of the reason why I've I spend a lot of time thinking about Salem and Sal, because
Yeah.
those languages actually came from precisely from trying to solve that problem of okay, I can take and return multiple values. Those values are the number of values is statically known. What
Hmm.
kind of interesting composition can I do with that information? That's part of the motivation behind Sal.
Yeah, I see. Um, cool. So then we have list functions, which is again without tail call in some of them. It's gonna be a little like um, triggering, I guess. So for
Uh,
instance, length.
and
This is not tail call.
yeah, no, it isn't. The problem is that this definition of length
This
is
is though.
terrible. It's not. Yeah, that is actually okay. But the length is terrible. Like an experienced Lisper would never write it that way. If you're in Common Lisp, you would probably use a looping macro or just use the built-in function. I'm pretty sure there is one in the Common Lisp standard library. If you're in Scheme, I don't recall. Yeah, I think length is in the standard library, but even if you just have to roll your own, you wouldn't write it like that because you're doing a recursive non-tail call in a situation where you don't have to. Like, why are you using stack space just to add one? That's like, it's not ideal.
Yeah, again, I think it's completely fine for newcomers to
I
read
think,
this. They will understand it.
yeah, I
Uh,
think for yeah, I think for newcomers, for trying to introduce people to this sort of stuff, that's actually okay. It's not okay from a practical perspective, like to actually want to use that length function.
I don't think so. I think it's pretty practical. If you don't care about performance at all, it's fine.
Um, yeah.
Because the main,
By the
or
way,
if you are also, for some random reason, interacting with the stack in your program, maybe in that case also. Not in this language though. You don't have access to the stack in this language.
yeah, you don't have continuations in this Lisp.
Yeah. So then we can define the last item. We have take. We have drop. We have split, which by the way, I believe is a split that doesn't exist in OCaml. So there's something there. This language has it. We also have
Racket
the
has it as
Racket
well,
has
but
it.
I think it has a different name. But yeah,
uh, so we also have LM, which is basically like indexing. Then he understands that we are repeating a lot of stuff. This pattern he is
yeah.
repeating a bunch. So let's create a function for that, and then he creates map. So we have examples of map as well, which is kind of cool. Then we create filter, which also works. And I didn't remember this when I was from back in when we were implementing join, but apparently join gets rid of the news, which is kind of cool.
Well, yes, because join is actually well, it doesn't. The reason this new is removed is because like um, this is inside of an if. So the if is going to evaluate that quoted new and will give you just the new back without the wrapping. And then join is actually the list concatenation operator,
Yeah,
not the cons.
yeah,
And of course, concatenating the empty list to another list is just the other list.
yeah,
So that's
yeah. No,
why
but
the
I thought it
new
was kind of
disappeared.
clever that from back in the day he was already thinking about that when doing join, and now this just works. That's cool. Then we made fold as well, which is very interesting. And then you can define some sum and product in terms of the fold.
Classic, very classic.
Yeah, very classic. Then we have now some conditional statements. So we're talking about like switch and case. Uh,
This is another function that I don't like for the same reason as I don't like unpack. I call it select when it's clearly conned. Like this is just conned.
yeah, this
Why
is
don't you
cont.
call it conned?
That's also true. This is cont.
And the otherwise is very Haskell-like. Haskell-y? What's the adjective for something that
Haskell-y.
feels like the
Haskell-y. Yeah, it is very
yeah,
Haskell-y.
because
Yes.
yeah.
Um, so then he explains that this is actually a little bit differently. A little bit it works a little bit differently than Switch because Switch also always compares one thing to multiple other things, and in this case you can do whatever because you can have whatever predicates in here. And then he says, okay, let's create a case then, and then this is a more like switch C like switch case, and we end up doing a Fibonacci just for loss. So I would say that aside from the
This implement
indentation, go on.
this implementation is terrible, by the way.
It is not terrible. It is just not tail call. For me, it's
No, no, it is
completely
ter it is,
newcomer friendly as
no,
well.
no, it is terrible because it's the naive implementation of Fibonacci, which I think is exponential if I'm not mistaken.
Yeah, again, because there are many ways of doing Fibonacci. All right, you can use with tail call, you can use a memoization strategy, you can use co-recursion. There are many ways to implement Fibonacci. But I think this is a textbook naive implementation. I'm fine. But what would you do differently aside from the tail call?
Uh, let's see. Yeah, no, I think the tail call is the most straightforward way to make it not terrible because this language doesn't have memoization in any way.
Yeah, doesn't have memoization. Yeah, and
By the
then
way,
oh,
if this language was had memoization, then this implementation would actually be fine. Like in Haskell, this is just okay because it turns out that the worst possible implementation, which is this one, if you memorize it, it actually becomes the best possible implementation, which I think is kind of funny.
yeah, I guess so. But when you say it's the best, like it even competes with the tail call version.
Yeah, it's actually they call it dynamic programming, but it's really just
They call
memoization.
it dynamic
Where
programming, but it is memoization. Yes.
yeah, because because here's the thing, you have to compute lots of copies of the same
Mhm.
Fibonacci call at
Yeah.
each recursive step, right?
Yeah.
And the memoization gets rid of of those copies, so you only have to compute each
On once.
Fibonacci number once.
Yeah, I already did this before.
Yeah,
And this is a pretty famous optimization strategy in like competitive programming. You immediately like just like recognize the pattern. You're gonna compute the same thing many times. You just memorize it. And people, because it's C++, you already have that embedded from the libraries. People already have like a template in which there is a memoization function in some templates that you just pass. Like there's a global thing, and then you just pass the key and the value, and it just goes. Um,
Nathan, please don't write Python code in the chat.
Let's go now to the bonus. So the first thing that is pretty interesting is more types, right? More types, because right now we only have very bare bones.
We only we only have numbers and strings
Yeah,
and lists, I guess.
yeah. So then he suggests to do a double, and he also suggests to do type promoting, right? Type promotion, because he wants to be able to use the plus with an integer and a double, uh,
Yeah, that's
which
very standard. That's very standard Lisp stuff.
no,
Mind you, I don't like it because it involves
it's
floating point numbers, and I hate floating point numbers.
I'm okay with. Well, I understand the problem with floating point numbers, but I think it's cursed to do the promotion. I would rather make my functions explicitly converting them myself than the compiler doing something
Um,
that I didn't ask for. So that's my take on it.
I wouldn't mind the implicit casting if it was to a rational, but he's proposing doubles, which are not rationals. So yeah.
User defined types. Uh, so this is basically, well, he suggests to do it like in a C type of way. So you basically create structs. I don't know how hard would it be to create something like an ADT using a struct. I haven't thought
Uh,
about it.
it's actually pretty easy. I thought about it a lot because I work with Lisps in general a lot. And the first time I saw an ADT in Haskell, when I was learning about Haskell for the first time, I was like, okay, how would I implement this in a Lisp? And the answer actually is I would use a list or a struct or some kind of aggregation primitive, right? And I would use a symbol as the first element of the aggregation, the same way we do with S expressions, right, for function calls. And the
Yeah,
symbol is the tag,
yeah.
essentially. It's a tag unit,
I think that's what
except
we did actually in the Spoon days, when we were making the simply typed system F stuff. We actually used like a pair, I think, or some sort of tuple, and we carry the tag and we carry the value and just go. Yeah, yeah, I lied. I do
yeah.
know how to do that. Yeah, I did that before. I definitely remember that.
And like if you implement this on the C side and then you hide or perhaps you generate the tag on the C side and you hide it from the Lisp side, you can have like generative closed types where you generate a tag when you define the type, right? The tags plural because there can be more than one.
Mhm.
Um, and then because those tags are not accessible from outside of the types and are only used for checking, you can't forge values of those types like by hand. So you can have
Mm.
some build time validation there if you want as well because of that.
Mhm. Mhm.
Not build time, construction time. Yeah.
Okay, so you're suggesting to like forbid if I have a tag odd, forbidding having a 4. Is that what you're saying?
Uh, yeah, because if you look at how records, well, they're called structs in Racket.
Yeah.
But when you define a struct, there's a predicate to check the struct
Yeah,
type,
we use
right?
those. I do know that.
We use those, yes, but you actually don't get the actual tag that tells you this is that struct, right? You don't get that in userland. You get the predicate, you get the constructor, but you don't get the tag itself, which means you can't build those up by hand. You have to use the primitives provided by the language.
Mhm.
Uh, which means that if you attach a guard to the constructor, you cannot bypass the guard ever.
Mhm.
You see, and that's how you would do some kind of validation in a user-defined type. Yeah, I think this is an interesting topic, and there are actually quite a few design decisions to be made here. So I actually like the fact that it's something that the author, proposes as a direction to explore.
Yeah, I need to get more into that because I don't know if I followed through until the end of what you said. Like Manhattan also said opaque types, opaque data type. So it is when you don't have access to the data of the tagged union. Is that what you said, Marinho?
Yeah, basically. The type is opaque in the sense that the only way that you can interact with it is with the primitives provided when you defined the type. So the constructor with whatever guards are used in the definition and whatever accessors you deem fit to provide as well. So like uh, And of course, you can choose not to export them from the module where you created the type, so you can have even more hiding that way. Um, yeah, but the point is, the important part is the fact that this is essentially just a basic tagged union, except the tag is not accessible, which means that any validations that you decide to attach to the constructor of the type cannot be faked, I guess, is the better way to
But
put it.
if you do the tags from the C side, you could. Yeah, your internet is going crazy right now. Is this because of me? Nathan, how is the internet of Marinho going? It's me? Okay. So, okay, I think I'm back. Uh,
Lemos, are we okay?
yeah, now I can hear you.
Okay,
So let me put
and we're
back my
back.
stuff. Okay, so you were saying that I asked if you make the tags embedded, then you could, right?
Yeah, if you embed the tag directly in the definition, like in the constructor, the predicate, and you don't expose the tag, the user can't actually use the tag to fake a value that you would expect to have been validated, but it wasn't because it was hand assembled with the tag and whatever.
Yeah. I see now. Then you can make some checking. Your microphone changed. It's more muffled, I think.
Oh, it's because I'm actually holding it in
Mm.
my hand.
Okay. Okay. So then we have the list literal. This is basically syntax sugar, right? Uh,
Yeah,
Nothing too crazy about that.
I yeah, it's okay, but like I don't see the point. I would rather have additional data types like maps and sets and have
No, but
literals
he's
for
not denying
those.
what you said, Money.
Yeah, he actually even acknowledges that you use up the square bracket characters, which could possibly be used for more interesting purposes. Like, I think the idea here is he just throws this out there as like, hey, here's a cool thing you can do, even though like you use up the characters that could be used for even cooler things.
Yeah,
So
sure. But I think this is probably one of the easiest ones because it's basically parsing.
yeah, it is.
Then we have syscalls, which yes, we learned that the hard way. You should have syscalls. Uh, you should definitely have syscalls.
Shout
uh,
out to Chime, by the way.
yeah, shout out. And he says that to this to be even be considered a scripting language, you need to have syscalls. There's no freaking way. The point of quote the point of running a program is to have an effect, and he has one effect which is printing, but he wants more effects. Uh, then we go to my problem. So he starts by saying that this def in other Lisps that you are allowed to write this, and then he says that this is a macro. I never thought about this as a macro. Never. For me, this is just a simple define, like whatever many Lisps you have.
Uh, It
Uh,
kind of is and it kind of isn't. Typically in Lisps, the primitive form for defining of a named value is something called a special form, in that it's kind of like a macro, except there's no definition for it anywhere. It's actually baked into the language runtime or the compiler.
mhm.
But for practical purposes, it's indistinguishable from a macro.
So this is not evaluating this. Is that what you're saying?
Yeah, the point is that the x there, if def was a function, it would try to evaluate the x, which is obviously nonsense because we're trying to define x. So evaluating it here would fail,
Mhm.
essentially.
Okay.
And yet, if def is a macro or a special form or what have you, it may not necessarily evaluate the x, in which case, yeah, it can actually say binds the value 100 to x, which is what he
Sure.
suggests here. The point being, the symbol x is outside of a Q expression, which in this particular Lisp
Mm-hmm.
would be required to avoid evaluating the x.
Yeah. So I don't have anything bad else to say. Like he said, not about like what I'm highlighting right now. So yes, this can introduce some magic into the language. You can do very powerful stuff with having proper macro
Um,
system. And I'm not gonna deny that. That's 100% true. You can do crazy shit. You can even make a type system using a macro system, a static type system, I should say, using a macro system. We have typed racket, right? So that exists. Um, and he also says that he liked the way that he developed the def and the if without resorting to macros using the Q expressions, but you are free to change it if you prefer. But what problem do you
uh,
have with this, Martin?
my problem is that I don't think macros are a good idea in general, um, at least in the context of a Lisp, because here's the problem: you are introducing a construct which is not first class. Like the if you just type def and it's not the first element of the list of a list in enclosure, for instance, that would actually be an error because the symbol def is not actually bound to anything. It's a special form. It's baked into the language, and macros are also the same. Like if you just say, what's an example of a macro? Um, I think when is a macro. If I recall correctly, it expands out to an if.
Mm-hmm.
If you just type when and it's not the head of a list, it will also fail because when is not actually defined as a runtime value, right?
Yes.
So you are looking at a construct which is not first class, and this kind of runs counter to the overall design of the language. Uh, I would argue that it would have been more appropriate to suggest something like F expressions, although since you already have a baked in notion in the language of things to evaluate versus to not evaluate in the form of the lists and Q expressions,
Yeah.
uh, you may have to kind of, I guess, rethink the design a little bit to make F expressions fit, but I think they would fit better than macros.
I
Because
think.
an F
Yeah.
expression
Go.
is kind of like a function, except it just doesn't evaluate its arguments. But it is a first class thing. You can say in kernel, which is the Lisp defined uh, by John Schutz, who is the person that wrote the theoretical formalization of F expressions. In kernel, you can just say def outside of like the head of a list, and it will evaluate to the F expression that defines a variable, like as a first class thing,
Mm.
the same way as it would if it was a function.
Sure, but I think like just to wrap this up because I have time today. Sorry for that. I think he's proposing to make it first class. Actually, maybe the reason that he didn't do it, the reason that he made Q expressions is to avoid maybe sending a message that what he thinks about macros. Who knows? But he said that he likes the way that he did some things without resorting to macros. But I believe that what he's proposing would require you to make it the first class. I don't think with the language the
Uh,
way that it is, you well, that's not actually true. Maybe there is a way to make this using Q expressions, but I don't think that's what he meant by proposing this.
yeah, personally, I'm a bit more partial to read time evaluation. Um, so like in Common Lisp, you can say hash dot, and that will evaluate the next form inside of the reader, actually.
Yeah.
And this is at least as powerful as a macro
Mhm.
because a macro runs like before evaluation, and this is also running before evaluation, so you can do basically the same things as a macro.
Mhm.
But notice that this doesn't need to introduce any new constructs to the language. You can just have a normal function and evaluate it at read time.
Yeah, yeah. But you need to have that
And it will have
granularity. You need to do that. To be able to do that.
you need to add this ability to the parser of evaluating codes, which Common Lisp already has, as I
And it's
mentioned.
not
I
like that hard if I think about when I think about it.
No, it isn't. It isn't. Um,
Yeah.
But yeah, I prefer that way of doing things because it avoids the issue of having macros. You just have regular functions that you call inside of the
Mhm.
reader,
Mhm.
and you still have the same power as macros because you do have that phase separation that macros also introduce.
Yeah.
Um, but you don't have this new concept, which is a second class citizen that you can't manipulate the same way as the ordinary values. You sidestep that entire issue. And you don't resort to F expressions, which wreak havoc on compilation.
Yeah. Yeah, but I think we that's a pretty good summary. They are more better, like more interesting maybe alternatives. That's a good way to put it than macros because then we can avoid some of the problems with it. I think that's pretty fair to say. Next
Yeah.
topic is variable hash table, which basically means that we should have, in order to not do linear search, we should have something a little bit more performant. And he suggests a hash table, which it's
Yeah,
completely
I
fine.
think yeah, it's sensible. It's
Yeah.
sensible.
Then we have
I don't have a
another
problem
hot
with that.
take, which is this. Uh, I thought that when I was reading, like, okay, he's gonna talk about the memory management now. I thought I would be able to see a realloc going on here, but he decided to go one step further and say, why not just literally allocate from the beginning of the program a bunch of memory and do the memory managed yourself? Who needs to rely on the OS? Like,
I mean, you kind of need to do this anyways if you plan to introduce a garbage collector at some point.
but that's the
So I
next
don't see
section,
why
right?
not.
That's the next suggestion.
Yes, it is. It is.
Yeah, but I
And
thought it was kind of funny that his first suggestion about the memory stuff, instead of going through like a realloc meet step, you're just gonna allocate an arbitrarily amount of memory and do the memory management yourself, which is like not trivial. This is a
it
non-trivial
isn't, but
task.
it's a good No, it isn't, but it is a good exercise all the same, and it does have interesting applications.
I'm not denying all of that.
One suggest, yeah, one suggestion for pool allocation specifically is something that is mentioned by one of the Zig people. I don't remember his name, but there's a video on YouTube about allocators from one of the Zig guys. Yeah, arena allocation. And he mentions specifically that this particular strategy is actually very useful for web servers, actually,
Mhm.
because you get a request, you you create an arena, you do all your allocation inside of the arena, don't bother with freeing anything, and then after you are done handling the request, you can just destroy the entire arena in just a single step, and that's more efficient than doing allocs and frees during the handling of the request.
Yeah. Okay. But again, I'm not saying denying what you said, Marin. Of like, you can. There's a bunch of stuff interesting that you can learn by doing that yourself, such as arena and stuff like that. That's awesome. But I was very surprised that that was his first thought. Like, let's just go because non-trivial task. You can lose your sanity by doing this. Probably you're gonna go insane if you try to understand the allocator from any OS, Linux, Mac OS, or Windows. You're gonna go completely out of the balls.
But that's
Especially
the
because they
thing. You
lie
could
a
just
few
say,
sometimes. So.
yeah, but that's the thing. If you allocate an arena, you can just do a bump allocator inside of that, which is very trivial. You just keep a pointer to the next free word.
Mhm.
And then whenever you need to allocate, you copy the pointer, return it. But before you return it, you bump that pointer by the size of the thing that you allocated. So it keeps pointing to the next free word.
Yep.
That's very efficient. It's very easy to implement, and it lends itself nicely for a garbage collector later on.
Yep.
Which
Which is what he's
can
suggesting
I
here.
just say? But can I just say that mark and sweep is a terrible first suggestion?
I don't know how hard it is. I never
Because
implemented, so I don't have any comment
because
on it.
if he's because like if he suggested pool allocation, the natural follow-up is actually a semi-space collector, not a mark and sweep.
Sure.
Uh, just to explain real quick how a semi-space collector works is um, basically divide your memory in half. Okay. One half you call the from space, and the other you call the to
Oh, I
space.
know that.
So
I
you
think Zozin did a video about that. Oh yeah.
yeah, so you do all your allocations on the from space until that fills up,
Yeah.
and when that happens, you copy the live data to the to space, which will also have the additional benefit of avoiding fragmentation because you
Yep.
can copy the
Yep.
data
Yep.
as you move it.
Mhm.
Then you flip the two spaces,
Yeah.
and then you continue from that.
Yeah. That's basically it. That's exactly what I remember. You when you do
Yeah,
you transpose the data from one side to the other, you get rid of the fragmentation, and you keep doing that.
yeah. And the reason I mention this is because this is actually the natural follow-up from doing pool allocation.
Sure. I do have only 5 minutes, so I think I want to speed this up a little bit. I think it's a good idea for suggestion in implementing garbage collection. Maybe this is not the best strategy to do it, but again, I don't know how hard it is to do any of them because I never implemented one myself. Maybe that's a project for another day. Then we have the tail call optimization. So yeah,
I
so
already
three more.
ranted about that the first time. He should have treated it as a go-to that passes arguments. Portraying it as a loop is kind of the wrong mental model, but I already said all that. I'm not going to repeat it any more than I
That's
already
kind
have.
of misleading what you said because doesn't say that it is a loop. It is a loop with a special description. It is a special loop that does whatever accumulate total step by step means. And that is, I think, where he missed the opportunity because he could have expanded what does this mean? What this means.
I think that's a red herring because the point actually is that this mental model of tail calls is wrong. A tail call is fundamentally a go-to, and you can build
You're
loops
not
out
wrong.
of that. That's fine. But if you don't think about it that way, you are missing the point, in my opinion.
I disagree. I fundamentally disagree with what you said. I almost never think of tail call optimization with GoTo. The only instance that I did frequently was in Chime. Every time otherwise of that, I was thinking about a completely different thing. I was not thinking about GoTo ever. Um, so I think that maybe you're gonna argue, then you're missing the point, Lambos, and I'm gonna say, fine, but I think I understand the what tail call optimizations work, even if I'm not thinking about GoTo. Which I'm not. I said it. You're not wrong. You are completely not wrong. But I never think about it like that because usually it's not useful for me in whatever high-level programming language I'm using. The only thing that I think is I want to get rid of the burden of the stack because it takes time and I'm using the stack unnecessarily. There's no go-to in what I said. So that's my point.
I guess that's fair. My main problem is actually with the fact that by saying that tail call optimizations boils down to converting a function to a while loop.
No, that is.
Like
I'm not
that's
saying this is good. I'm not saying this is good. I'm just saying that if he wanted to say this for whatever reason, he judged that maybe this is a newcomer friendlier version of whatever the go-to version is. I think he did it midway through, which ended up being poor. I think
yeah. I think this is way too
yeah,
this is way
exactly.
too narrow. It's way too
Exactly.
narrow.
So if he
Um,
wants to say this, fine, but you need to add a lot more to not put people on fundamentally non-useful mentality.
yeah.
That's the thing. Uh, Lexicoscoping. I don't
This is
remember.
really just this is really just checking
Oh,
that you're not
checking.
using an
Yeah.
undefined variable.
Yes. Yes. This is just
Which,
checking that.
first of all, for this to be useful, you have to fix that scoping bug that I
Yeah.
mentioned a few sessions back.
Yeah.
But secondly, this would break the REPL if you are not careful. So
Yeah.
be mindful of that.
And finally, just because it's the hottest, is to make a static type system. I don't think we need to extend on this. Marinho prefers dynamic typing for the reasons that he studied. I prefer static. Natan prefers static. Magenta prefers static,
Uh,
and
I
that's
think the
fine.
main problem with I think the main problem with static typing, specifically in the context of Lisps, is that it doesn't play very well with metaprogramming.
That's true, and I think that's undeniable. I think that that's a trade-off that people need to put in whatever the application they're building, whatever the product is. And if metaprogramming matters, probably you're gonna have a hard time to do this. Also, interactive development, we cannot also deny that. If you, I think it's trickier to make the interactive development cycle work with static typing and stuff like that. Although, even regardless of that, implementing this I think would be a lot insightful for the person that is attempting to do it.
Yeah,
Very,
it
very
would
insightful.
be.
Okay, so now this is just a thank you. I think the book. um I think if it had more observation tiles throughout the book with the things that we said throughout the sessions, I think it would be miles better. Even like approaching, I don't have many complaints about it. I may have a problem with some naming that strategy that he chose, but I don't have many problems with it. The way that it is right now, it is okay. But I think if you are not aware, if you never did this, a programming language before, I think it's fair to say that if you take this book at face value, some of the things you're gonna do highly inefficient, and he's not
Yeah.
telling you that, and he should. So I think that's the my take on it. I want to do a final session trying to maybe implement one of those, or alongside fixing the scoping issue that you found before, Marin. I don't know which one we're gonna do, um, but I really have to go now. So final comments, Marin.
Yeah, I think the book is okay. It could have been way better, but like if you're just starting out and you want to have some ground to stand on, I think this is okay.
Yeah.
It's better than starting with Python anyways.
What a Chad. So I'm gonna finish the recording now.